You know that feeling, right? That little jolt of panic every developer gets. Wait, did I just commit a secret? We're talking about those digital keys, passwords, and tokens that we all accidentally leave lying around in our code. Well, today, we're going to build a solid game plan for hunting down and fixing these leaks before they turn into a full-blown catastrophe.
So let me ask you straight up. Are you 100% sure there isn't some forgotten API key buried deep in your Git history somewhere? Because for a security pro, that's not just a passing thought. It's a ticking time bomb where one tiny mistake can have absolutely massive consequences.
All right, first things first, let's really get our heads around what we're up against. This is section 1, the leaky codebase problem. We're going to dive into the hidden dangers that are way more common than most people think. So, what exactly is a secret when we talk about it like this? Well, to put it simply, it's anything that grants access. I like to think of it like a house key. You wouldn't paint your front door key bright orange and hang it on the doorknob, would you? Of course not. But that's pretty much what we're doing when we hard code a password or an API key right into our source code. And this happens with all sorts of incredibly powerful keys. We're talking cloud API keys that can literally control your entire infrastructure, database passwords that unlock all your customer data, even private SSH keys that give someone a direct line into your servers. Every single one of these is a wide open door for an attacker. And here's the bottom line. The stakes could not be higher. Seriously, it is not an exaggeration to say that one leaked AWS or Azure key, if it has enough permissions, can lead to the complete takeover of your company's entire cloud environment. That's why having a plan is not just a good idea, it's essential. Which, of course, brings us to our next section, your secret scanning playbook. Okay, so we've talked about the what and the why. Now let's get into the how. This is all about setting up a proactive, automated system to hunt these secrets down before anyone else does. So, building a really solid program boils down to 4 key moves. First, you got to pick your tools, the software that's going to do the hunting for you. Second, you run a big scan of everything you've already got to see where you stand. Third, and this is the real game changer, you build that scanning right into your development pipeline. And finally, you have to make sure that when a scan finds something, the right people get an alert, like right away. Now, this is really interesting because it shows the 2 main lines of defense you have. Think of pre-commit hooks like the spell checker in your word processor. It tries to catch your mistake before you even save the file. Super proactive. Then you have CI/CD integration. That's more like the final proofreader who checks the whole document before it goes to print. It's a central safety net that catches anything that might have slipped through. To be really safe, you absolutely need both. Okay, theory is great and all, but let's walk through what this looks like in the middle of a real crisis. We're going to break down the anatomy of an incident right from the moment a key gets leaked to those first critical response steps. It so often starts with that sinking feeling in your stomach and a message just like this one. It's a simple, honest mistake, right? A developer is moving fast, they push a commit, and boom. A super sensitive Google Cloud Platform key is now sitting in a public repository for the entire world to see. The clock is officially ticking. And just look at how fast things can move when you're prepared. At 2:02 p.m., the bad code is committed. But because of that CI/CD scanning we just talked about, an automated alert fires just 3 minutes later. 3. By 2:06, the security team is on it. We're talking less than 20 minutes from the initial mistake to a full-on remediation plan kicking into gear. That kind of speed is literally only possible with automation. Okay, so the leak's been spotted. Now what? Well, that brings us to the most critical phase of all, the multi-cloud cleanup. This is so much more than just deleting the bad code. It's about making absolutely certain that leaked key is completely and totally useless to anyone who might have found it. And here is your emergency playbook. The first rule when a secret is leaked is simple. You must assume it's been compromised. You immediately revoke it, no questions asked. For AWS, that means you deactivate or delete the access key. For Azure, you revoke the service principal's credential. And for GCP, you disable the service account key. Then, as a totally separate step, you rotate it by creating a brand new, clean key to take its place. Now, killing the key is the technical fix, but believe me, that's only half the battle. You also need a rock-solid communications plan. The right people, security, DevOps, maybe even legal, they all need to know what's happening immediately. You have to figure out if an attacker actually used the key. And, maybe most importantly, after the fire is out, you have to do a post-mortem to learn from what happened and make sure it never happens again. So, at the end of the day, a successful response really just comes down to these two things. First, you contain the damage as fast as humanly possible. And second, you treat the mistake not as a chance to point fingers, but as an incredible opportunity to learn and make your entire system stronger. So, you followed the playbook. You rotated the key, you reviewed your process. The immediate crisis is over, and your vault is secure. For now. But the thing about security is you're never really done. So the real question I want to leave you with is this. What's your next move? How are you going to get ready for the next one? Because in this world, it's never a matter of if, it's always a matter of when.